Hi, so welcome back to Let's Crack JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. Here is my profile. So I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and in this session we'll continue differential equations. So today we are going to discuss solutions of differential equations. I have already taken one session on differential equation. But before we begin, let me tell you about the Unacademy's subscription. So as you know, Unacademy is India's largest online learning platform, and you can subscribe for IIT-JEE. So two types of subscriptions you can buy on Unacademy for IIT-JEE. One is Plus subscription, and another is Iconic subscription. So in Plus subscription, what do you get? Let me tell you. So when you get a Plus subscription, you get access to daily live classes of all the educators who are teaching for IIT-JEE. All means all physics, chemistry, and maths. You also get their live sessions, and you can watch their recorded sessions also. Like if you miss something, every session is recorded, so you can watch recorded sessions offline as well by downloading them. Okay, you will get that option of downloading, and all the live tests and quizzes will also be accessible to you. All these courses which I am talking about are well structured, so you can see the schedule of all the upcoming lectures in well advance. And also you can follow the educator of your choice. That is up to you. So there's complete freedom. Okay, so you can join a course or you can follow individual educators of your choice. Okay, so this is unlimited access which you get on Plus subscription. These are the subscription charges. You can subscribe for 1 month, 3 months, 6 months, 12 and 24 months. For 12 months it is 38,500, and after 10% discount it is 34,650. Similarly for 24 months it is 56,000. Okay, and after 10% discount it should be 50,400. Yeah, one more thing, you can use this referral code to get 10% discount, JEET1. All right, and second is Iconic subscription, in which you get all the benefits of Plus, and apart from that you get a personal coach who will guide you throughout your preparation for top exams. Okay, your test analysis will be done in a personalized manner. Your study planner will also be customized. Bi-weekly reviews will be given to you, highlighting your progress. Okay, and your personalized feedback will be given to you to improve your time management and exam approach. All right, so this is Iconic subscription, which you can buy on Unacademy, and these are the charges. For 12 months it is 56,000. Okay, and for 2 years it is 86,000. Of course you get 10% discount by using the same code, referral code JEET1. You can use and get 10% discount. All right, now this is Unacademy's learning app, which you can download from Play Store, and after downloading you can start your preparation. You can attend special classes for free. Okay, you don't need to take any subscription for that. So every day a lot of educators take a special classes on the Unacademy's learning app, so you can just attend any unlimited special classes, any number of special classes, without buying any subscription. Okay, so there's a lot of stuff which you can see on Unacademy's platform, like YouTube channels and Unacademy's special classes. These classes are also live classes. Okay, so you get the feel of the platform by attending the platform. So you can see, you can interact with your educator during the live session, you can chat with your educator. Okay, so all the features you will be able to see. So just download this app and start your preparation. All right, now as I told you, today we are going to begin differential solutions of differential equation. Okay, so the first solution, is first method to solve differential equation is variable separable method. All right, so in this variable separable method, what happens if dy by dx, suppose dy by dx is the simplest and easiest solution, and such kind of equations you have already done in physics. Okay, or many a times before this chapter. Okay, So whenever dy by dx is given something like this, f of x into g of y, okay, that means you can split if you have a function of x and y right hand side, or an expression having x and y, then you should be able to express this expression as a product of two separate functions of x and y. Okay, if you are able to do it, then you can separate function of y and put it with dy. So g of y, dy upon g of y, and the function of x with function of x with dx. Okay, so that is fx dx. So in this way you can separate the variables, and now you can integrate easily, because this is a function of y which you need to integrate with respect to y, and the second side, right hand side, you can see it's a function of x which you need to integrate with respect to x. Okay, so now you can do the integration and solve it, and after solving it you'll get the equation of family of curves whose this differential equation was given. Okay, so let me give you an example for this. Suppose fx is given, dy by dx is given. Yeah, so dy by dx is given sec square x into, say, cot y. Yeah, this is very easy example. So now how to do it? You can see x and y are already given in product form, function of n, function of x and function of y. So you can separate these two functions. Dy, you need to write dy upon cot y. Okay, separate this function of y, and sec square x, you can write with dx. Okay, now you can write this tan of y dy. Okay, integrate it and integrate this sec square x with respect to x. All right, sec square x with respect to x. So you know the formula of tan of y, it is ln of sec y, right? And you can put mod whenever you have log. So there's simple integration, and integration of sec square is tan x. So this will be tan x plus integrating constant. Okay, so this is your final solution of the given differential equation. All right, so I hope it is clear. Now let me give you another example, example number 2. I'll give you time to solve it, so you try it. It is not always visible that it is function of x into function of y. You might have to do some work for that, like in this example. See, check out 1 plus x plus y plus xy. Okay, although it's a very simple question, but yes, start with this. Okay, start with it, try to solve it. So I hope it is done. Now let me solve it. So it is dy by dx is equal to, now see, if you write 1 plus x as it is, 1 plus x, and take take y common from the last two terms, it is 1 plus x. Then you can take 1 plus x common, so 1 plus x into 1 plus y, and this dy, now you can separate it. Now you can see there's a function of x into function of y. So it is dy upon 1 plus y is equal to 1 plus x into dx. All right, now see, you can integrate it easily. Integration of this, it is ln of 1 plus y, and the integration right hand side is also extremely easy. It is x plus x squared by 2 plus c. Okay, so in this way you can solve it. This is the solution. It was an easy problem. You just needed to express it in variable separable form. All right. Now let me give you another example. Example 3. So this is 1 plus y square. Because we are starting the chapter, so I'm giving you some easy examples to practice. 1 plus y square dx into 1 plus x square into dy. In this form equation is given. So sometimes they write equation in this form, like some function of y or x into dx plus some function of x or y into dy and is equal to 0. So you can separate dy by dx. And in fact, whenever you have dy by dx, you ultimately separate dx and dy. So in this case, he has already separated it. But you need to write dx with function of x and dy with function of y. That is the main point, okay? Alright, so let me do it. So you can write 1 plus y square dx is equal to minus of 1 plus x square into dy. Then you can separate. You can write dx upon 1 plus x square is equal to minus of dy upon 1 plus y square. Alright. Then after this you can integrate easily, right? So integration of, by taking integration both hand sides, you can write tan inverse of x left hand side is equal to minus of tan inverse of y, right? That is the formula, plus c. So final answer is this: tan inverse of x plus tan inverse of y is equal to integrating constant. Even you can apply the formula of tan inverse x plus tan inverse y and you can separate tan inverse also, okay? So you can express, you can do some more manipulation in this, depends how in which form answer is given. So this might be given in the option, okay? So you can answer this. Now let me give you another example. In this, dy by dx is given sine of x plus y plus sine of x minus y, okay? So try this one. All right, then let me do it. I hope you have done it. Now, dy by dx is equal to, if you apply sine c plus sine d, or even you can apply sine a plus b. So that is, so 2 sine c plus sine d is 2 sine c plus d. So if you add these two angles, that is 2x by 2. So it is x into cos c minus d. So that is 2y by 2 is y. Okay. Then you'll get this dy upon cos y is equal to 2 times of sine x dx. All right. Now you can integrate it, right? So you know the formula of sec, this is going to be sec y dy is equal to 2 times of sine x dx. Okay. Now let's integrate it and let's try to find an answer. So final answer is going to be integration of sec x dx. Integration of sec theta with respect to theta is ln of sec theta plus tan theta. So sec y, not theta, in this case it is y. So it is sec y plus tan y, sec theta plus tan theta, mod you can put if you want, is equal to 2 times of integration of sine x is minus cos x, so minus cos x plus c. So that is your answer. Okay, so we have done this. So I hope you understood this. Now let's move to another example, number 5. Now you have this. Dy by dx is equal to y dy by dx is equal to e raised to, wait a minute, let me bring some change in this. It is e raised to y 1 plus e raised to 2x plus e raised to 2y plus e raised to 2 times of x plus 2 times of y. Alright, this is the function. Try to solve it. It's again an easy problem. All right, so let's do it. Now you can do it as e raised to y dy while dx as it is. Let's try to separate it. So you can write like the, for example, I have given you 1 plus x plus y plus e raised to xy. So this can be written as 1 plus e raised to 2x plus e raised to 2y as it is, plus this can be written as e raised to 2x into e raised to 2y. Now you can separate it, this factor and in this. So it is 1 plus e raised to 2x plus it is e raised to 2y. If you take common, it is 1 plus e raised to 2x again. So finally you can write this 1 plus e raised to 2x into 1 plus e raised to 2y. Now you can separate it, and e raised to y dy by dx. So e raised to y as it is with dy divided by this function of y, which is 1 plus e raised to y whole square, you can write, and this is 1 plus e raised to 2x as it is into dx. Now see, in this you can do a substitution. Now you need to integrate it. So this is, if you put e raised to y is equal to t, then dy e raised to y dy is dt. So it is f dash upon 1 plus fx whole square. So directly you can write tan inverse of e raised to y is equal to, this is x plus e raised to 2x divided by 2 plus c. All right. All right. So I hope this is clear. Now let's do second method, which is convertible to variable separable method. Convertible to variable separable. Now see how to do it. So if we have dy by dx is equal to some function of a linear equation like ax plus by plus linear in x and y, then how to convert this such equation in variable separable form? So what you do, you can write ax plus by plus c is equal to t. We use this substitution to change this to convertible variable separable form. You see, if you have this example, I'll give you dy by dx is equal to x plus y. Okay. See, can you do it? Can you separate x and y? If I write dy by dx is equal to x into y, then it is very easy to separate, right? You can put x with dx and y with dy. But in this case, when you have dy by dx is equal to x plus y, now you can't separate. Although this is a this is extremely easy problem, but directly you can't separate x and y, right? You can't put x with dx and y with dy. So to do this, you need to substitute x plus y is equal to t. This is the example of the method we are doing. So you have any function of a linear expression of x and y. In that case, that you need to put that linear expression of x and y is equal to t, and after that express dy by dx in terms of dt by dx. Okay, so how to do it? Differentiate this equation. So you'll get a plus b dy by dx is equal to dt by dx. All right. So dy by dx can be written as dt by dx minus a divided by b, and this will be equal to f of t. All right, f of t. And then you will have dt upon dx minus a is equal to a times of b times of f of t. Now you can see it is only a function of t, so it is done now. Dt upon dx is equal to a plus b f of t. And now you can write dt with this function a plus b f of t. So a plus bt is equal to dx, right? Now you can integrate it. So it's separated. dt with function of t and dx is with 1. There's no function. Okay, so now you can integrate it easily. Now let's do this example which I have written it here. This example, dy by dx is equal to, say, x plus y plus 2. All right, so this is a very easy example. You need to put x plus y plus 2 is equal to t, and after doing so you will get 1 plus dy by dx is equal to dt by dx, and you can replace dy by dx is equal to dt by dx minus 1 is equal to, put this x plus y plus 2 is equal to t, so it is going to be t now. As simple as that. So this is dt upon dx is equal to t plus 1 now. You can write dt upon t plus 1 is equal to dx. Alright, now you can integrate it. Alright, if the integrating, will get ln of t plus 1, ln of t plus 1 is equal to x plus c. So you can leave the answer in this way, or sorry, not you need to put t. So first you need to separate t plus 1 is equal to e raised to, you can write x plus c. Okay, and put the value of x, put the value of t. So it is going to be x plus y plus 2 plus 1 will become 3, and e raised to x plus c. You can write the answer in terms of ln also, or this. Both are. So it depends what is given in the option. In that form you can leave the answer. Alright, so this was the solution. I hope you understood this. Now let's do another example. Now solve this. Dy by dx is equal to sine of x plus y. Solve it. Put x plus y is equal to t. Okay, so in this case we'll start with the substitution. X plus y is equal to t, and differentiate it. So it is 1 plus dy by dx is equal to dt by dx. Alright, so dy by dx is equal to dt upon dx minus 1, and this is going to be sine of t, then dt upon dx is given equal to sine of t plus 1. Alright, then we can separate it. Dt upon 1 plus sine t is equal to dx. Now how to integrate it? So now it's a question of integration. So it is dt upon 1 plus sine t is equal to dx. So to integrate this, what you need to do, multiply and divide by 1 minus t. It will become easier. This is an easy method to integrate it. 1 minus t, and niche it will become 1 minus sine square t. So we have multiplied and divided by 1 minus c, 1 minus t, and this is dx. Now it is going to be cos square, so 1 upon cos square is sec square t, minus sin t upon cos square is basically sec t into tan t, okay, dt, and is integral of 1 dx. So this integration of sec square is tan t, minus integration of sec x tan x is sec integration of sec x tan x is sec x, so it is sec t, and is equal to integration of 1 with respect to x is x. Now you can put the value of t. Alright, so if you put the value of t, it is going to be plus integrating constant also. So now you can put the value of t, and that is x plus y, so that is tan of x plus y minus sec of x plus y is equal to x plus c. So this is the answer, okay? So I hope this is clear. Now let me give you one more question to solve, and then we'll move to next method. So that is sine of x plus t, x plus y sine of x plus y plus cos of x plus y, okay? So this one last question based on this method, and then we'll start another type of equation. Alright, so let's start with the same by putting x plus y is equal to t. So if I put x plus y is equal to t in this, we'll get 1 plus dy by dx is equal to dy by dx. It's very similar to the previous problem. Now I'll get dy by dx will be replaced by dt by dx minus 1, and this is going to be sine t plus cos t. So it will become dt upon dx is equal to sine t plus cos t plus 1. Alright, and now you can see you can separate it. So this is going to be dt upon sine t plus cos t plus 1, all right, is equal to dx. Now how to do it? Now we do it using half angle formula. Okay, so you need to apply half angle formula of sine and cos, then you can integrate it. So what is half angle formula? In terms of tan, you put dt upon sine t ko you can put 2 tan t by 2 upon 1 plus tan square t by 2 plus cos t can be written as 1 minus tan square t by 2 upon 1 plus tan square t by 2 plus 1 is equal to dx. All right. Then 1 plus tan square t by 2 you can take to the numerator, and this is sec square t by 2 basically, and it will become 1 plus tan square will be LCM tan square. So let me write completely, tan t by 2 plus 1 minus tan square t by 2 and plus 1 plus tan square t by 2 is equal to dx. All right, this tan square and tan square will get cancelled, and it is going to be sec square of t by 2 dt divided by, now it is going to be 2 tan t by 2, so 2 you can take common, and it will be tan t by 2 plus 1, okay, and is equal to dx, 1 dx you can write. Now if you put tan t by 2 plus 1 is equal to u, then its derivative is sec square t by 2 into 1 by 2, which you have completely right. So it is basically this whole thing 1 by 2 and sec square t by 2 dt is the derivative of the function written in the denominator. So it is like f dash x upon fx, and whenever you have f dash x upon f dx, it is ln of fx, all right, plus c. So it is going to be ln of 1 plus tan of t by 2 is equal to x, okay, plus c. So that is going to be the answer. All right. Okay, so this is the answer. This is the final answer. So I hope you would understand it. Now let's do another method, which is homogeneous equation. So first of all, let me explain what is homogeneous equation, then we will start solving it. So any equation which suppose you have an equation f of x y, okay, this is an expression of x y, okay, so you call this equation if this is an homogeneous equation, then if you replace x by lambda x and y by lambda y, then it should be equal to lambda times of n f of x comma y. That means you can take lambda raised to n common, okay, then this equation, then it is called homogeneous equation. This is the property. This is a way of expressing homogeneous equation. In a simple words, if I say, then all terms should be of same degree, okay. I'm not writing a differential equation, I'm writing a simple equation in x and y, like x square into y plus x cube plus y cube is equal to 0. This is a homogeneous equation in x and y because you can see each term has degree 3. Even if you can multiply constant is not our concern. Constant you can multiply, any constant you can multiply to any term, okay. The sum of powers of x and y should be equal in each term. So in this case you can see this is third degree homogeneous equation, okay. Similarly in differential equation, whenever you have a differential equation, if I write some examples, then it is like root x into y raised to 3 by 2 into dx plus x square dy plus y square dx is equal to 0. I'm not considering the degree of dx or dy, or even you can consider them degree 1. Otherwise, leaving these terms, you can see the powers of degree of each term containing x and y is basically 2. 1 by 2 plus 3 by 2 is 2. This is 2. This is 2. Okay. So each term is of degree 2. All right. So this is one of the way to express it. Now, if I give you another example, like if I write dy by dx is equal to x cube plus y cube divided by x y square plus yx square. Is it homogeneous equation? Yes. You can see if you cross multiply, then you can write x y square plus yx square into, leave dy by dx, or you can write dy is equal to x cube plus y cube into dx. Now you can see this is third degree term, third degree term, third degree term, third degree term, right? So each term is of 3 degree. Another way of understanding this is, finally, if I tell you the final thing, then if it is a homogeneous equation, then it can always be expressed as dy by dx is equal to some function of y upon x. Okay, some function of y upon x. So dy by dx can be written as f of y upon x if it is a differential equation. Okay, if it is a homogeneous equation, sorry. Okay, so you can always in the previous example, let me show you. If you take x cube common in this from denominator as well as from the numerator, then dy by dx can be written as x cube. If you take common, it is 1 plus y upon x the whole cube divided by, if you take y cube x cube common, then it is 1 plus this is y square upon x square plus y upon x. All right, so you can see this whole thing is a function of y upon x. Okay, so homogeneous equation can always be expressed in terms of as a function of y upon x. Okay, homogeneous equation can always be expressed as dy by dx is equal to f of y upon x. Okay, so how to solve it? Okay, now to solve it, you need to put y upon x is equal to t. That means y is equal to xt. All right, y is equal to xt. Then what you can do is you differentiate it, so you'll get dy by dt, dy by dx, differentiated with respect to t. So dy by dt is equal to x into differentiation of t with respect to t is 1 plus t into differentiation of x with respect to t is dx upon dt. Oh, I'm sorry. We need to differentiate it with respect to x. I'm sorry. I was differentiating it with respect. We are putting y is equal to xt, so we need dy by dx in terms of dt by dx. So we need to differentiate it with respect to x. So it is dy by dx, all right, is equal to differentiation of x is 1, so it will be t only, plus it is x into dt upon dx. All right. Like this. So dy by dx is going to be t plus, now put back in this equation, so it is going to be t plus x dt by dx, and now you can see it is going to be a variable separable form. See this, you can separate the function of t easily. X dt by dx is equal to f of t minus t, and now it is going to be dt upon f of t minus t is equal to dx upon x. Alright, like this. So now you can integrate it. Now you can integrate, okay? So in this way you can solve it. So I hope it is clear. Now let me give you one example. If you have dy by dx is equal to, say, x square plus y square upon into, say, x square. Alright, you can see this is a homogeneous equation of second degree. Solve it. Solve it by putting y is equal to y upon x is equal to t. Okay, so let me solve it. So put y upon x is equal to t. Okay, then rest of the process is same. Put y is equal to xt. Okay, and then dy by dx, it is always t plus t plus x dt by dx. So put in this equation, it is going to be t plus x dt by dx is equal to 1 plus t square. Alright, so this x dt upon dx is equal to 1 plus t square minus t. So it is dt upon 1 plus t square minus t is equal to dx upon x. Integrate it. So now you know how to integrate a quadratic, right? You need to make it a perfect square. So you make it a perfect square, and it is going to be t square minus 2 into 1 by 2 into t, so 2ab plus 1 by 4 plus 3 by 4. Okay, this way you can split the terms. Is equal to, this is ln x, right? You can integrate this plus c. Now left hand side is going to be dt upon t plus 1 by t minus t minus 1 by 2 the whole square. Okay, and plus it is root 3 by 2 the whole square. All right, is equal to ln x plus c. Now you can see it is going to be tan inverse of t minus 1 by 2 upon root 3 by 2 and tan inverse of x upon a and 1 upon a also. That is the formula of dx upon a square plus x square root 3 by 2 is equal to, this is ln x plus c. All right. So this is going to be the answer. Okay, so now you can put t in this equation. So you can put t is equal to, get t is equal to y upon x. Okay, so put in this and that will be the answer. So I hope this is clear. Huh? Now I'll give you another very simple equation. Now you can solve dy by dx is equal to sine of y upon x, right? Solve this. Now this is already given in the function of y upon x, so you know how to solve it. Okay, so put y upon x is equal to t, then you can get y is equal to xt again, and then you can write dy by dx. So that part is same for all the homogeneous equations. So dy by dx is equal to again same t plus x dt by dx, and now it is going to be t plus x dt by dx is equal to sine of t. Now it is x dt by dx is equal to sine of t minus t. Alright, and you can get tt upon sine t minus t is equal to dx upon x. Alright, now you need to integrate it. So now you need to integrate this one. Alright, so now you can do it and finish it. I think I've given you a wrong. Alright, so now next, let me give you another example. This x into x minus y dy by dx plus y square is equal to 0. Alright, let's solve it. So you can divide by x square, and it is going to be 1 minus y upon x, and dy by dx as it is, and this is going to be y upon x. As I told you, if it's a homogeneous equation, you can always express this as a function of x and y. So whatever is the degree, I mean just find out the degree and divide by x raised to power, x raised to degree, whatever degree you are getting. Okay, to whole equation you divide by x raised to n, and you'll get this function, this equation as a function of y upon x. Now you can put y upon x is equal to t, and then same dy by dx is equal to t plus x dt by dx. So this is going to be 1 minus t, and this is going to be t plus x dt by dx plus, or right, is equal to plus t square is equal to 0. So you can write t plus x dt by dx is equal to, this is minus t square upon 1 minus t, alright. Then you can take t common, so it is x dt upon dx is equal to minus t square upon 1 minus t minus t, alright. So it is x dt upon dx minus t square. If you take LCM, it is minus t plus t square upon 1 minus t. This t square and t square will get cancelled. So this is a t minus 1 upon t dt is equal to dx upon x. Now it is going to be, now you can do it easily. So 1, this is dt minus 1 upon t dt and is equal to 1 upon x dx integrated. So this is t minus ln t is equal to ln x plus c, and you can put the value of t y upon x. So final answer is y upon x minus ln of y upon x is equal to ln of x plus c. Alright, so this is the final solution. Alright, so these were the methods. So we have done, the 2 sessions are completed. In first session we understood what is a differential equation, how to find the order and degree of a differential equation. So we did sums based on that. Then we did formation of a differential equation of various family of curves. Now we are finding the solutions of a given differential equation. So we started with variable separable method, okay. Then we did convertible to variable separable. Then we are doing homogeneous differential equation, solving homogeneous differential equation, which is also a method to convert a homogeneous equation to variable separable, okay. Ultimately, whatever differential equation you have, you finally convert it to variable separable, okay, or maybe exact form. Exact form I'll tell you later, that is very, very interesting, okay. So now the interesting methods are about to come. As first order linear differential equation, which is very, very important. We'll do that in upcoming session, next session. And one more type is there, convertible to homogeneous, and then after that we'll learn that first order linear differential equation. And first order linear differential equation also has a various types in it, convertible to first order linear differential equation, and along with that we'll learn exact form also. So exact form is very interesting. So if equation is not of any of the type, like homogeneous or this and that, whatever methods we are doing, then there will be only one method, and it is exact form. So I'll explain the exact form, and if you understand that exact form, then it's going to be very, very interesting, okay, for differential equations. So today I'll keep up to here, and then I'll see you in the next session. Thank you very much. So thank you for attending the session. Like and subscribe the channel, okay, and use the code JEET1 to get 10% discount if you are subscribing on Unacademy for Plus or Iconic, okay. So thank you very much again.